So guys, the most often comment, the comment I wrote the most, and I want to make a little stamp out of it, was division not last. I wrote that so many times, it hurts to write it right now. Again, please, dear God, don't take this like I'm coming down on you. This is just, these are things you should know. Maybe it's been a while. Maybe you were even taught wrong. Sometimes I've heard teachers actually teach that multiplication always comes before division, which is bullshit. So if you were taught something like that, you were taught wrong, if it's been a long time, I understand those things. Right? That doesn't mean you're off the hook. It just means, all right, you're aware of it, and now you better step up and figure it out. Right? PEMDAS is like the grammar of math, which is why it's so difficult. The grammar of any language is hard, right? So what I really want you guys to realize is, for example, what is 5 minus 2? 3. It's amazing. So anywhere in the universe, I see 5 minus 2, I can replace it with 3. But something like this here stumps the hell out of people. Right? You start to think, oh man, FOIL, or you give me 25 minus 4. No. See, exponents, again, real quick. Exponents are based on what operation? What are exponents based on? Multiplication. So what operation will they play well with? Multiplication. What operation is in the parentheses? They ain't going to play well. You can't distribute that because it's not an operation that it's based on. Does that by itself make sense? So you can't make it 25 minus or plus 4 because that operation is not what it's based on. It's not going to be like that. All right, let me stop there. Oh, I did. So I don't know if any of you have been told this kind of thing before. Something like this, why can I distribute this? And let me make it more in your face. Because what are coefficients based on? Addition. What does 2x mean? X plus x. So why am I allowed to do this? Why is it so easy? Because this is based on the operation that's in there. It should be easy. They should play well together. I like it. This, no. What am I squaring? What is 5 minus 2? There, that's what I'm squaring. That's why the first thing in order operations is parentheses. You do inside the parentheses first, so then you know what the hell number that is, so they can do the shit that's all around it, right? Does that make sense? All right, I like it. Believe it or not, every step you take in math has got to make sense. It's not just arbitrary shit we said, yeah, that sounds good. It actually has a cohesive reason why it works. And then the next, so if I did 3 squared, the next thing in order operations, of course, is exponents. So then I would make that 9. Is that cool? I like it. Something else that drives me a little crazy is, what if I had this? Let's just build this up. There we go. That's looking more like what was on the quiz, right? So this, yeah. Parentheses first. You don't give a crap about anything else first. So the less comfortable you are with order operations, the more you do them lockstep, right? When I say lockstep, I don't mean P-E-M-D-A-S. I mean P, and then E, and then M or D as they come, and then A and S as they come. Because just to blow your mind a little bit, there is no division. There is no spoon. There is no division. What is division? Multiplication by the reciprocal. So division is still multiplication. That's why they're at the same level. Neither one is more important than the other. You do them as they come. How are we doing so far? Is this? Yes, ma'am.
So it's like whatever order they come in left to right.
Thanks for laughing. Huh?
Whatever order they come in left to right. Okay?
Yes, cool. So we'll do another one specifically about that here in a minute, because that was the other part of this problem. This isn't exactly like what you saw in the quiz. It's missing some stuff. But just to build. So what would I do first here? Parentheses. I don't know what I'm squaring. And I don't know what I'm doubling because I haven't done this yet. You guys see how to look at this. So 6 minus, I don't know. What's the last thing I'm going to do here? Subtraction. Why? Because it's at the end. That's why. Right? Okay. So this 6 minus 2 is going to keep repeating for a while. 5 minus 2 is 3. That's crazy. So I'm done with parentheses. There's nothing to do inside the parentheses. What do these parentheses indicate right now? Multiplication. Good. That's why I left it there. I didn't write this very often, which is really nice. Multiplication cannot become addition. What do I mean by that? Real quick on the side here. If I had like 2 times negative 3 squared, I had people writing 2 plus 9 on the next step. It was like negative 3 squared is positive 9, but that was multiplication by 2. Now it's adding 2. Now, right? That's like water into wine shit, which would be a very useful ability to have. Sorry. All right. Back. There should be 2 times 9. I don't even need that little dot in there, but I'm just being really. And then 18. Flow. So what would happen here next? Yes, exponents are next. Right? The parentheses, nothing inside left to do, so why are they still there? Because they indicate multiplication. So this is 6 minus 2 times 9. And then you get too many people tell me 4 times 9, 36, done. No. Because remember, subtraction is going to be last. Why? Because it's at the ass end of PIMDAS, right? So then this will be 6 minus 18, which in this case is negative 12. Don't freak out. This is not something that was on the quiz. It's just an example. Oh, I didn't get negative 12. Okay, that's probably good. All right. Here's the other thing that I was talking about a second ago that troubles me. So if I had something like this, 18 divided by 9 times 2, division is not last. Where is the D in PEMDAS? It's like in the middle. But so many people did, and again, that's why I wrote this so many times. Division is not last. All right? And I know why you guys think it is. Let me come back to this in a second. Here's why you guys think division is last. What would you do last in this problem? You would divide last. Because that big bar means divide the top by the bottom. But how would this look if I wrote it in a single line? It would not be this. If I wrote it like that, I'm so desperately wrong, because what's the only things dividing if I write it like this? 11 and 8. No, I'm supposed to divide the top, bam, bam, by the bottom. Now that's why division is last, because everything else is in parentheses, and they automatically go first. I think that's why people think division is last. It ain't. Right? Okay, I like it. Just to use wrong grammar. So here, this is not 18 divided by 18. No. You do it as it comes. It's on the MD level. 18 divided by 9, 2. 2 times 2, 4. I like it. And again, if you write this as 18 over 9 times 2, you have written a different problem than what I gave you. Because what's the only thing that I'm dividing by in that statement? 9. That's it. And then I'm multiplying by 2. So how the hell did the 2 get down here? It should be 18 divided by 9 and then times 2. That's the right way to rewrite it if you wanted to. You don't have to. All right. How are we doing so far? Is that good? A little bit? Okay, maybe. And I'm not saying, uh-oh, what's up?
Can you just multiply 9 times 2?
No. So that's the whole point of what I just said. What's the only thing dividing in this problem?
Oh.
The 9. Yeah, so I would divide 18 by 9 and then multiply by 2. It isn't, this is a different problem, right? Let me make sure you guys understand. That's wrong. Okay? Because how the 2 come down there? No. What's the 2 doing? Multiplying. Why would it be on the bottom? Like it. Some of you guys look like you want to hurt me, but channel that into studying. And if you don't think this is important, well then, you are insane, right? Numbers, how often do they happen every day? Constantly. All frickin' time. So if you don't know how to do it, you're going to disagree with another group. of people, and things happen. Like there's a Mars thing that we sent up, the climate, I can't remember which Mars thing it was, kind of a survey satellite thing, and one group was using one set of units and another group was using a different set of units, and it smashed into Mars because their programming wasn't correct. You guys kind of follow? Now, I'm not saying you're going to become jet propulsion scientists, but I'm saying in general, you got to know how numbers frickin' work. We created numbers. Out of nothing, we made numbers. We should know how the hell they work. Okay. Out of nothing. Sorry, I just watched Guardians of the Galaxy Volume 2 finally. Great ball. Sorry. Let me see. That's it on PEMDAS. Something else, I did a little quick lecture in the labs, 2 of the labs, not all 3. So I just want to really quickly say this again, or for the first time for the people in that one lab. What's 2x plus y plus 3x? 5x plus y. You don't have to subtract anything. They're all on the same side. So this is 5x plus y. Now, the exact same reason this is true is the same reason, what is 2 ninths plus 1 eighths plus 3 ninths? What can I combine without doing anything else? Yeah. So what's the general idea? 2 somethings plus something else plus 3 of those same things. I can combine the things that are like, right? 2 somethings plus 3 somethings is 5 of those things. Are you with me? So I was saying, like, if I have 3 chairs and 5 tables, I don't have 8 table chairs. That doesn't make, what the hell? That doesn't make any sense. Are you with me? You understand? I can only combine things that are like. Consolidation, that's really all like terms is. And what is an LCD? It's making it like terms. Right? I can add 4 eighths and 1 eighth, because that gives me 5 eighths. So if it doesn't have the same denominator, it's not like terms. But then I can make it have the same denominator. Okay. 5 ninths plus 1 eighth. 5 things plus 1 other thing. 5 things plus 1 other thing. And then, of course, here I can make an LC. Keep going. Okay. Let me think. Was there anything else, Jeff, that you wanted to go over? Oh, and of course the properties were just, oh my God. The distributive property should have been the nice one. A lot of you guys just didn't read the instructions and you're trying to solve the problems. Listen, I didn't say solve. I told you there was not going to be any equations on this thing. So there was no question about solving. It was just tell me the property, right? So it's either commutative, associative, or distributive, right? Distributive should have been very obvious, so then you had a 50-50 chance on the other ones. And I love how everybody spells commutative with an N. Like we all live in a commune, right? It's commutative, like you commute to work. Now, I'm not going to take points off, but still I'm going to circle the N and go, what? Communes? You guys know history about communes? All right. Okay. I think that might be enough about that. All right, guys, anything about what we just spoke about? So guys, who remembers the quick way to remember if it's commutative? It's if what moves? No, if the parentheses get up and move, that's associative. All right? So parentheses associate, individuals commute. Like you did this morning. You drove here, or you biked here, or you walked here, or you took the bus, right? Or you flew, or you swam. I don't know, a body of water near. I don't know how you do that. All right. So that's how I remember it. Individuals commute, parentheses associate. So if I add this, what actually moved? Did the parentheses move? Are they covering different things? No. They're still covering the 8 and the A. So what moved? The 8 and the A. Individual things move, so that would be commutative. I like it. Okay. Anything else about stuff we just talked about? Anything else before we get back into new stuff? Oh, associative would be this. What actually got up and moved? The parentheses got up and moved. I like it. Could have been. Again, only one person got a 0 because they cheated, because they put answers that were nothing related to their quiz. So I kind of warned every lab. I said, hey, there's many versions of this quiz. So be careful. Wandering eyes will screw you up. So I will not hesitate to give you 0. If that person cheats again, they will fail the class. So cheating is remarkably stupid on so many levels. So don't do it. Yes?
So, was each, I know that there was only like 2 questions, but.
Oh yeah, each part. So
Yeah.
I would say there were 8 questions or whatever there was.
Oh, okay, because I missed this one. Yeah.
Oh.
So I just want to.
Oh, the properties.
Yeah.
All right. Well, that's an easy one to make up. Right? You just have to remember somehow what the words mean.
Oh, okay, never mind.
I like it. It's better than making a mistake on a process and not knowing why it depends on stuff.
Okay.
Yeah. Okay. Anything else before I get back into where we left off yet? All right. Okay. So, what is x? So, for example, let me see if you guys are cool. What is x plus x squared? Oh shit! Please think about it for a second. No, I don't see 2x squares up there.
Oh no.
X to the third. I don't see any x to the thirds up there. I can get that. It's done. You can't do shit. Why? Because those are not like terms. So guys, even if you think it's a trick question, I'm not grading you. I don't care. That's not a trick question, by the way. That's just a like terms question. You guys with me? Realize this. Again, this will always save your ass. What are exponents based on? So they will only change if the problem involves multiplication. We say it again. Exponents are based on multiplication. So they will only change when there is multiplication in the problem. I mean, does that make sense? So this, you can't do shit with. But what is x times x squared?
2x squared.
No.
3x. X to the third.
All right, guys. Just to remind you guys. So this is x times, and what's x squared? X times x. So of course that would be x to the third. Right? I don't see 3 of anything right now. You guys, you with me? So do you see how multiplication is much more relaxed than addition? So multiplication and division don't require exactly like terms. Addition, subtraction, you have to have exactly like terms. So to show you an example, can you add 1/9 plus 2/5 directly?
No.
Some of you can, but stop. It's no good, right? It's not 3/14. You can't put this, I got 1 something plus 2 something else. I can't say that's 3 anythings. Right? Is that cool? But what is 1/9 times 2/5? 2/45. I like it. Why can I do that? Because multiplication doesn't require like terms. You're not trying to consolidate things. Multiplication is a different thing than addition is like consolidating. And subtraction too, consolidating your debts, and consolidating your credits and your debits and whatever. Balancing your checkbook. Are you guys kind of with me? So addition, subtraction will always need exactly like terms. Multiplication, division? No. In this case, it just needs like bases up there for variables, right? Fractions can just go to 10. It doesn't matter what they are. You just multiply across. Hopefully you reduce before you do that. Now, reciprocal, in what situation would I multiply by the reciprocal? Okay, so if I had 3/7 divided by 2/5. That would be multiplication. So is it 7/3, is that right?
No.
Hell no. Good. A few people did that. It's always the second dude that gets turned around. And I know, I totally understand that when I derive something, it's painful to look at. I understand that, because deriving something is really getting at why things work. So remember how I derived this? 3/7 over 2/5. Oh, I already don't like that, Jeff. All right. Don't do it this way. Somebody did it this way, and you got it right, but oh God, you don't have to do it this way. This was just me explaining, why is it the second guy? Why do I turn the damn thing over? Those should be things you should be like, tell me, because I don't understand why. Don't just, I'm going to do it because that's what they said. It's got to make sense. So again, the idea was I multiplied by the reciprocal on the bottom to make it 1. That's the best bottom to have, right? A bottom of 1. And so this equals this, bam, done. There's the proof. So you don't flip the first guy, that makes no sense. Flip the second guy, because that's the guy that would be on the bottom that you want to kill. Maybe, maybe? A little bit? No? What's up?
That just like confused me. I don't know. Like, you said not to do it that way.
Okay, so I will very often show you why things work the way they do. And in order to do that, I have to go a lot more behind the scenes than you ever have to. So to be honest, dividing fractions and multiplying by the reciprocal is a shortcut. It's built on this. Do I want to see this? No. But you should see it at least once to see why the hell that rule works. Don't just accept it. That's what the math dude in the front of the room said. No, screw that. Sometimes the math dude in the front of the room is wrong, which really sucks. Yes?
So do you multiply 3 and 2 and 7 and 5?
Definitely not. No. 3 times 5, 15. 7 times 2, 14. I like this.
Oh, so you do it cross.
Totally, of course. No. The only time, and look how slow I'm talking. So this sounds like a note that you should put a big box around, stars, arrows. The only time, I'll write it down too in my own language here. The only time you cross multiply is if you have a fraction equal to a fraction. If you have an equation with fractions in it. So something like 7 over x equals 5 over 3. And then cross multiplication is itself a shortcut. So stay with me. I like this. We're exploring. I love it. I don't know if you guys realize, if you look at the timeline, I built in time right now in case what happened, which is we got to go back and look at some specific things. I just didn't know what to go back and look at until I gave you that quiz. Now just stay with me. I want to show you where cross multiplication comes from. Do you guys remember how to kill fractions here? Like, how would you kill that 3? You would multiply both sides by 3. And so it cancels. So what does it look like the 3 did? If I just wrote on the next step 3 times that over x, it looks like the 3 just came up here. Is that really what it did? No, I multiplied both sides by 3, but isn't that what it looks like it did? The 3 was here. Where's the 3 now?
Over there.
Up there, right? Now how would I kill the x? Multiply both sides by x. So they cancel here. So what's it look like the x did? Went up there. So then I get 21 equals 5x. So just to start over again, if I have 7 over x equals 5 over 3, the shortcut is 3 times 7 is 21. 5 times x is 5x. Then of course you would solve for x by dividing by 5. I love it. And somebody's got to stop writing 4 there. Some of you guys are like, yeah, that's about 4. No, 21/5 or a mixed number, right? It's about 4 billion. No, you're off by 1/5 of a billion, which is a lot of dollars. So don't overly round things. I don't care how much you hate fractions. They are very often the answer, right? So this case, that's the answer. That's the only time ever that direct cross multiplication is the right thing to do. That's the only time. And it's just a shortcut. It's not even a thing, to be honest. It's just what we call the shortcut we made. Yes?
Can I write that specifically? Can you go like 4 1/5?
Yeah, exactly. 4 1/5. I love it. It's not 4, 4 1/5. I like it. That 1/5 could be huge. It's no like billions of dollars. I like it. All right. How are we doing so far? Do you guys start to understand that for me, I live off of why does this work this way? And that's my freaking job. My job isn't to tell you how to do shit. My job is to explain to you why shit works the way it does. Right? So I live off of questions. I do. Okay. Anything about that right there? Is that decent? All right. So I'm going to get back into where we left off. And that was with word problems. Oh, yeah, and I wanted to steal some from the book. Oh, here we go. Oh, look, they come with the answers. All right. All right. I love this problem. The sum of 3 consecutive, and you can see I have some dirt now. The sum of 3 consecutive page numbers is 60. Right? And I don't know, have you guys ever heard of this kind of problem?
Yes.
Yeah.
And some of you guys are like, oh shit. But here's the idea of modeling. Give me an example of what the answer could be.
31.
Yeah, 31, 32, 33. That would be consecutive page numbers. Or they could call it consecutive integers.
Oh, I was like,
19, 20, 21, 40, 41, 42. What's got to be true? Whatever the first number is, the next number is one more than that, and the next number is going to be related to the first one is 2 more than that.
yeah.
No matter what the answer is, that's got to be the relationship between the 3 things. So when we write the math names, we're capturing the relationship they have to each other. When I set up the equation, I'm going to find the specific things that have that relationship that make it work. Oh shit, what did I just say? So for example, do we know what any of the numbers are? Yes, you do, if you saw before I covered it. Yeah. And this is where, real quick, I got to have a little discussion about, somehow I'm going to bring driver's ed into this. When you solve a word problem, you must use algebra. What's in the title of this class? Algebra. So I don't care if you get the right answer a different way. This is algebra class. So very often we have a word problem that's simple. So you can actually think of the answer in a different way, which is beautiful. I'm not saying that's bad, but you are in algebra class. So it's nice to know what the answer is supposed to be, so when you do the algebra, you know if the answer is right at the end. So what's it got to do with driver's ed? So if I was doing a driver's ed class and I said, final exam, drive to the mall and call me when you get there. So then you walk to the mall. Yeah, I'm at the mall. I got here. I got here. No, but you didn't use the right thing to get there. You guys see what I'm saying? So some people think just the answer matters. Well, that's great, but we are in a class learning a specific method. Because not every word problem in the world is going to be easy just to look at and tell what the answer is going to be. Appreciate it that it is right now. Do you understand that analogy? Because I know it's really frustrating when you get the right answer and then I take almost all the points off. You kind of realize what class you're in. If you don't use the stuff that the class is about, you're probably going to lose a lot of points. Right? Okay, maybe. And some of you guys just heard, I am an asshole, but oh well, I don't care, as long as you do it. Think of me as you will. So I don't know what any of the numbers are. So what's the first number then?
X.
Holy crap, that's even Whee! Yeah, the first number's got to be x. So then the second number's got to be x plus 1. And the third number's got to be x plus 2. So that captures every possible 3 consecutive integers. They have to look like this, right? I specifically want the ones that add to 60. That's where the equation comes in and says, that's an infinite number of things. I want the ones that do a specific thing. That's the equation step. You're forcing this to do a specific thing. And so how would I write that? Oh my god. X plus 1 plus x plus 2 equals 60. I like it. And now it should be the easy step, right? So this will be 3x plus 3 equals 60. Subtract 3.
Divide by
3x equals 57. Divide by 3. X equals 3 goes into 60 20 times. So 3 goes into 1 less time, 19. Oh shit, multiple. So if x is 19, then the second number is, that's crazy, and the third number is, holy shit. Now again, if you take 60, divide by 3, and then adjust it, if you were in my Math 120 class, which is a pure problem solving where algebra might be one way you do it, you don't have to use algebra, that'd be fantastic. Here, you're going to lose maybe all the points. Right? And I'm not punishing creativity. This is specifically an algebra class. You have to learn how algebra works. So hopefully everybody gets that. That's why that happens.
So if we do it that way,
The cheating way. I want you to understand. That's a beautiful way to do it. If only this class was a, like, do it any way you can class. But this is an algebra class. Holy shit. So you have to use the algebra to solve it. I love the way you're looking at me right now. That's too bad. But, I mean, that's the bottom line, right? The class you're in, if you're in painting class, and you take pictures and bring them in with a camera, is this going to work? No. You know, it's beautiful. It's well composed. It's fantastic. If it was a camera class, if it was a photography class, you make a ton of, you make great grades. But here you got to do it. I mean, that's that basic. It's that basic. Okay, maybe.
different kind of life.
Let's see. What about a different type? I forgot my book is magic. Has all the answers. What about? Let's do one. No. Yeah. Let's see. Here we go. So let me write this down real quick. About 2 billion mobile devices were shipped globally in 2013. The number of mobile phones, you can do it, Jeff. Mobile phones was 9 times the number of tablets. About 2 billion mobile devices were shipped. Looks like skipped, like they skipped it across the ocean. Shipped globally in 2013. The number of mobile phones was 9 times the number of tablets back in 2013. Where'd it go? How many of each type? So this is a classic word problem. It's not a geometric word problem. You can draw a phone if you want to. It's going to do shit for you. Right, so you don't have to draw anything. What are the players in this problem? Very direct.
Phones and tablets?
Yeah. Number of phones, number of tablets. So everybody should have that, hopefully the handout, unless you missed the last lab, and I have extra handouts they give you in lab, where they tell you, they go over the steps that we went over the other day. The first step, what are the players? The first step is pure English. In fact, you just kind of gloss over the two more than twice shit. You just kind of gloss that over and say, Frank and Harry and John's salary, those are the three people in the problem. It's pure English. The next step is, who's going to be just X? Yeah, the tablets. Why the tablets? Because the phones would be 9 times that, so I got to know how many tablets there were in the first place. Now, we don't know how many tablets there were, so how many tablets were there? I love saying that because I always get somebody like, you just said we don't know. What the hell's wrong with you? But in algebra, we always know. Is X. How many phones then? 9X. So now I can do math stuff with this because I've changed it into math names. And the math names aren't just like X and Y. Don't call something Y. Not yet. That's going to come into play later. I don't have to say that this is Y because it's directly related to this guy. Can this be anything it wants to be? No. If this was 5, this has to be 45. It can't be anything it wants to be. You guys see, that's why one thing is X and the other things are based on that. Because they all have a relationship with each other. So what's the equation going to come out to be then? Now here's the nice thing. You don't have to write all the freaking zeros. You can just say 2 and understand that all your answers are in billions. Billions. Yes?
So it doesn't matter that it says about 2 billion? You know what I mean? If it just said 2 billion.
Oh, yeah. Was it?
Okay. Sorry.
No, you're right. It's a little bit shaky, but we'll use 2 billion because that's the best thing we got. I like it. So now what's the equation going to be? I mean, here's the equation. What's the next step? Now it should be the easy step. Yeah, 10x equals 2 divided by 10 divided. It's kind of funny. 1/5, not 1/5 dollars, right? Dollars. That's how I say dollars. 1/5 of a billion.
Wow.
Yeah, so you can just take a billion divided by 5. That would be divided by 4, I think, what you said. So it should be 200 million. It's crazy. Are you guys semi with me? So that if you have like 10 million and 3 million, you don't have to write all the zeros. You just know all your answers are going to be in millions or billions or whatever the problem is. Could you put all the zeros in if you wanted to? Hell yeah. Whatever it is, you got to put it in there. Don't just say 1/5, because I'm like, they shipped 1/5 of a tablet. That doesn't make any sense. So how many tablets? 1/5 of a billion. What's a billion look like?
A lot of zeros.
Yeah. Can you be just a little more specific? So this is 1,000. This is a million. This is a billion. So 5, look, 5 goes into 10 twice. So that's 200 million. You guys with me?
Yeah.
So then how many phones were there then?
That was 18.
Yeah, so now 9 times 2, so this is tablets. 9 times 2 is 18, and then you just write all the zeros. Don't put the commas in yet. Bam, bam, bam.
We have to do all.
You could write 1.8 billion and 0.2 billion if you want to instead. You guys see that 1/5 is 0.2? It's like 1/5 is 2/10, which is 0.2. Maybe. Everybody's looking at the clock. It must be getting close. We're not quite there yet. Don't get excited. All right. But that's the classic word problem. There are a couple of players, maybe 3 players. You write the English names down. Figure out who's going to be X, build the other ones, and then what's the relationship? Do they all add to be something? Are they equal to each other? That kind of thing. I like it. Let me see, what else can I throw? One more, and then we'll get out. Maybe I can steal from the review from here. Yeah. Ooh, I like this one. I would. You have the blue book, it's number 16, page 28. So this is the last problem we'll do today here, right? And then some of us will head over to the lab and get our quizzes back. I'm going to do this, obviously, the algebraic way first. And then I'll show you a way that I can't accept, but I'll show you a different way to do averages. It's kind of nice. So a student scores 73 and 91 on the first two exams in Math 90. What score do they need on the third exam to still have an average of at least 80? Well, let's say exactly 80. Let's not bring at least into it yet. How the shit do you do this? So, how do you average numbers? You add them all up. Divide how many? After the third test, I'm going to have 3. One of the test grades is unknown, X. I love it. So, the third test grade is X. So what grades does the student have so far? 73? 91? X. I love it. So how do you average those 3 numbers? Add them all together. So 73 plus 91 plus X. No. How do you average? You add them all up and divide by 3. If that equaled 80, the last test could be a big old negative. And that means like you run your teacher over with your car and you get a negative grade. Well, don't try it, but I gotta be careful what I say. So you're gonna run me over and say, I'm just checking it, Jeff, to see what you're you guys get the idea here? I mean, this is, if there's an unknown piece, but I know what I want the average to be. In fact, now think about this. Here's something interesting about average. And now you see why this one problem is going to take us to the end. Hold on, because Jeff likes to talk about you. If I know that 3 numbers average to be 80, I don't know shit about those 3 numbers necessarily, right? In fact, one of them could be a billion, as long as another one is about like negative a billion. I mean, it just has an average to be 80. What does it mean they have to add to be? If 3 numbers average to be 80, I know what they have to add to be. Because how do I find the average? I add them up and divide by, in this case, 3. Well, what divided by 3 is 80? What divided by 3 is 80? What divided by 3 is 80? 3 times 80 is 240. So I don't know shit about the 3 numbers, but I know they have to add to be 240 if they're going to average to be 80. Do you guys understand this? Yes. So if I know the average, I don't know anything about any individual number, but I know what they have to add to be. So I do know something, right? Okay, and so that's why this next thing that happens in the equation makes sense. What's a good way to do this?
Add all those up to 240.
Multiply by 3. And then you get, see, I killed a fraction first, right? Just to save room, can I add these together? 164 plus x equals 240. Can you guys see that? Yeah. I don't know if you caught on to this, but I'm not used to using the projector. And then subtract.
76.
X equals 76? Yeah, 76. So let me show you a slightly different way to do that same problem, and then I'll let you out of here. That's the way I'd have to see it. Let me show you something kind of cool. This will just take a second. And you're like, yeah, better, because it's kind of, oh, I'm too bad. 73, 91, blank. How far away from 80? 80 is what I want, right?
Yeah.
How far away from 80 is 73? It's down 7 from 80, right?
Yeah.
How far away from 80 is 91? It's up 11. You guys see it? How far away from 80 is 73? It's 7 down from 80. 91 is 11 up from 80. Are we good with that? So overall, right now, I'm up 4. So how far down? I could be down 4 on this last test because I'm already over by 4. So this could be 76, down 4. That's what we just freaking got, right?
That's easy.
What? Again, was there any algebra in that? No. Well, I appreciate it if you understand that. Oh, hell yeah. If you write that on a test, you ain't going to get much points. Because there ain't no algebra in what I just did. Okay.